Hello everyone, welcome back to our SolidWorks course. In this video, we would be starting with a new module. The name of this module is Configurations. In this module, we will learn how to create different configurations of the same part. But specifically in this video, we would be learning how to use equations and design tables. What are these two and how do we use them in SolidWorks? Let's take a look. Let's move to SolidWorks and begin with our modeling. Here you can see that I have launched SolidWorks and now I will simply create a new part by pressing Ctrl N on the keyboard and then double clicking on part over here. Once we are in the new part, first I will explain you what would we be creating. In this video, we would be creating a simple nut. With the help of this nut, or rather the model of this nut, I will be showing you how to use equations. We will be only using one dimension as our defining dimension and we will reference all the other dimensions with this first one. Let's first begin with our modeling and I will explain you the rest as we move through the video. First, I will click on the top plane, go to sketch, and once we are into the normal to mode, I will first create a circle starting from this origin like this, and next I would be creating another polygon over here, something like this. Once I have both of these here, I will now move ahead and define my sketch. For that, first I will get into the Smart Dimensions command. I will select the circle and then give it a dimension of 10 millimeters. Once I have done this, now I will press escape first, select this line and make it horizontal. Once I have done this, I will get again into the Smart Dimensions command and I will give this dimension, that is for the outer diameter of 20 millimeters. The outer diameter for the nut is always 2 times of the nominal diameter. I want you to note the terms and the relations that I am telling you over here. This is a nominal diameter, this is our outer diameter, and the outer diameter is 2 times of the nominal diameter. Once I am done with this, I will go to features and from here I will select extruded boss base. Once we are into the feature, we'll specify the extrusion or the direction of extrusion from the mid plane, and here we'll specify this extrusion distance as 10 millimeters. Again, I want to note here that this is the height of the nut and it would be always equal to the nominal diameter. Once we have done this, I will click on OK and generate this nut. Next, what I would be doing here is that I would be sketching on this face over here. I will click on the face, go to the sketch mode, press Ctrl 8, set the sketching view normal to the screens, and next I will again select this circle sketch entity, create a circle starting from this center or rather our origin. I will end it somewhere over here, let's say over here. Next I will press escape, exit the circle command, select the circle, press Ctrl and then select this edge over here. I will leave Ctrl and click over here this option that says make tangent. Now you can see that my sketch is completely defined. Next I will go to features and from here I will select extruded boss base. I have done a mistake over here. I will exit the extrude boss base. I have to select extruded cut over here. Next I will specify the type of extrusion as through all. I will rotate this part over here so that you can get a preview of what I am doing. I will first mention the end condition as through all. I will tick this option that says flip side to cut. It will now flip outside the circle as you can see over here in the preview. Next I will add a draft of 30 degrees over here. I will enter 30 and you can see here that these are the edges that would be cut off. Once I am fine with the preview being shown over here, I will now simply click on OK and generate this extruded cut. You can see that we are near to creating our nut over here. Next I will go to the drop down of linear pattern and from here I will select the mirror command. I will specify my mirror plane as the top plane and here it has already taken the selection of cut extrude to be mirrored. I will click on OK and here you can see that we have created this cut over here on both the ends. Before moving any further, I will introduce you to equations. For that, first I will right click on annotations and from here I will take this option that says show feature dimensions. Once I have done this, you can see here it is showing me all the dimensions that we've used so far. The nominal diameter over here, the height of the nut, the outer diameter over here, and this angle that we created, or rather added. Once I have done this, I will go to the drop down of I over here, and from here I will make sure I select view dimension names so that the dimension names are being shown. Now let's first rename all these dimensions. I will simply click on this dimension over here, and then I will double click on this dimension over here. I will first exit the smart dimensions command. I will double click on this dimension. Once we have all the dimension and the names for the dimension on the screen, I will now simply click on this dimension over here and change the name of the dimension from under the tab that says primary value. I will now rename it as my nominal diameter. I have entered the name over here. I will click on OK, and you can see that the name has been changed over here. Next, I will change the name for this value over here. I will enter the name of this dimension as outer diameter. I will click on OK, and here you can see that the name has been changed. I will change the name for this one as well. I will name this as height. Click on OK and change the name here. We would not be needing this, as this would be constant in all the nuts. Next, what I would be doing here is that I will now introduce you to using equations. What I will do here is that I will right click on Boss Extrude, go to Edit Sketch, press Ctrl 8 and set this into the normal to mode. Next, here, as I have explained before, that this would be the diameter or the dimension that would be driving all the other dimensions. Now, I hope you remember the relationships I told you between these two. The outer diameter is always 2 times of the nominal diameter. So I will enter, or rather create an equation for this. I will double click on this dimension so that the modify tab is being shown up. I will press backspace, clear the value, and first I will press equal to. In order to create a new equation, you have to add an equal to sign. Now, from here, I will first select this diameter. You can see that once I have clicked on this diameter, the name of this dimension has been added over here. That is nominal diameter @sketch 1. It is showing me that this dimension is from sketch 1. Here I will simply add an asterisk and enter 2. If I press enter on the keyboard, you can see here, if I click on OK, you can see here that an epsilon sign has been added to our dimension, which was not present here, denoting that this dimension is now driven by an equation. If I double click on this and again open the modify tab, you can see that this equation is being shown over here, that is nominal diameter. If I move this side, you can see that nominal diameter into 2. This is the equation that we created. Now I will simply click on OK and generate this dimension. Once we are fine with this, I will now press Ctrl Q on the keyboard, exit the sketch, rebuild the part, press Ctrl 7, get into the isometric mode. Next, I will define this over here. For this, I will select this dimension, click on this dimension, and from here in the value, again I will press is equal to. In order to create the new equation, you always have to add equal to sign. And again I will click on nominal diameter over here. Once we have added an equation for the outer diameter, now we will add an equation for this height over here. For that, I will right click on Boss Extrude, go to Edit Feature, and here in the Dimension tab, I will clear this off first by pressing backspace. I will press equal to so that it starts an equation. You can see that a red equal to has been added. Now I will simply click on this nominal diameter over here. You can see that now this would be equal to the nominal diameter. I won't add anything else and I will simply click on OK. Once I have done this, you can see that we have another red epsilon sign over here, denoting that this dimension is also driven by an equation. Once we have defined these, Now I will show you where do we edit our equations, or I will first right click on this tab over here that says equations, and from here I will select manage equations. Here this tab has been prompted up. Here you can see all the equations that you have added over here. The first one is for height, the second one is for outer diameter. Next, here we would be defining a global variable which can be used wherever we want. Let's say here we enter this global variable as D. I will press enter, and from here it is asking me what should be the value for this global variable. Again, the value for this global variable would be our nominal diameter. Again, I will press enter, and here you can see that it is showing me the value for the nominal diameter that is assigned to the value of this global variable. I will show you where would we be using this global variable. If I click on OK, this variable would be added. If I go to the drop down of equation, now you can see that we have added a global variable, and this can be used anywhere in the part. We will now proceed and create a thread inside this nut over here. I will zoom in a bit so that we have a clear view. Next, from the drop down of Hole Wizard, I will select the thread option. I will click on OK and accept the warning. Here it is asking me the start of the thread location. I will specify this edge as the start of my thread, and from here the end condition that I will specify is up to selection. I will rotate this nut and specify this face as my end condition. If I press Ctrl 7 and set it into the normal isometric mode, here you can see that this preview is showing this is how the cut, or rather a thread, would be generated. Let's take a look at next conditions. From the type, I will specify the type as metric tap, and in the size I will specify my size as M10 by 1.5. Here you can see this is what our size is, M10 by 1.5. M10 denotes the size of the hole and 1.5 denotes the pitch of the thread. Here you can see we have specified our type of the thread that is supposed to be created. We have to cut a thread, so we will make sure that this option is on. If I zoom in, you can see that this thread would be generated on the inside, that is, a thread would be cut from this material over here. Next, the next parameter that we would be editing over here is the diameter. We will click on override diameter, and here this selection has been shown. Here I will simply press equal to, and from the global variables I will select D as the variable that is supposed to be added over here. Now why did we do this? I will explain that to you in a bit. But for now you need to understand how I am assigning equations and how I am strategically placing all the variables that I have created. We will keep the pitch as same 1.5 for all of them. And now once that I have done this, I will now simply click on OK and generate this thread. If I press Ctrl 7, you can see that there are a lot of other annotations or feature dimensions that have been added for this thread. I will just move them aside like this so that they don't overlap anyone. There are a lot of these, so we will simply move them away as much as possible. Here you can see that this is the dimension that we had created by using our global variable. Here we have an epsilon sign denoting that this is our global variable. Now what I will do here is that I will first summarize what all I have done. First, we created a nut by giving it a nominal diameter, and the outer diameter for the nut was referenced from this nominal diameter. That is, we added an equation that stated us, or rather that gave us the value of this outer diameter, which is 2 times of the nominal diameter. Next, we defined this dimension with the help of our equation. We assigned a value equal to the nominal diameter. Next, we created a global variable so that we could use it in all the other features, like we used it in the thread feature, and we also made the global variable equal to our nominal diameter. I hope all the things that we have done so far are clear. This is how we have used equations in order to create referencing between dimensions. Now I will introduce you to a new concept, that is a design table. For that, I will go over here, and from insert I will go to tables, and from here I will select design table. Once I have clicked on the design table, here it is asking me what should be the source. I will first specify as a blank design table, as I would be editing it myself. Next, here you make sure the edit control is on, allow model edits to update the design table. Here I will click on OK, and what it will do here is that it will now load the Excel sheet onto your SolidWorks. Like this. Here you can see that the format or the layout of Microsoft Excel has been loaded over here. Here I will specify my input parameter as nominal diameter. It is not showing it over here, no problem. We will simply click on OK and generate our design table. Here it has not loaded the table over here, not an issue. We'll again edit it by ourselves. But it has added a design table to this part. I will simply click on this graphic area over here somewhere, and it will exit the design table. It is telling me that no valid design table instances were found. Okay, we will go to this third tab over here that says Configuration Manager. I will click on it, and once we are into this Configuration Manager, you can see in the menu of tables we have a design table added over here. I will simply right click on this and select Edit Table. Once I click on Edit Table, you can see that it has created this Excel sheet over here again. I will press Ctrl and drag my part over here so that I have a clear view of the part and all the dimensions. Once I have done this, what I have to do here is that I have to enter the parameter that I would be modifying. In our case, I will simply, it is now, yes, it has aligned itself properly. Now here I have to enter the parameter that I would be modeling. In this case, as I have told you before, that we would be changing the nominal diameter only. So I will simply double click on the nominal diameter, and here you can see that it has added the nominal diameter and added the value for the nominal diameter for the first instance as 10 millimeters. Next, we would be creating a new nut, let's say of M12, and here it would be of 12 diameter. Next, we would be creating a M14 nut, and the nominal diameter for that would be 14. Next, I would be creating a M8 nut, let's say, and the nominal diameter for that would be 8 millimeters. Again, I would be creating an M6 nut, and the nominal diameter for the same would be M6. Once I have entered all the configurations that I want to create, I will now simply click on this red or green tick over here. If I click on this, here it will tell me from this prompt that the design table generated the following configuration: first instance M12, M14, M8 and M6. I will click on OK, and here you can see that all these configurations have been added over here. Now let's take a look if the changes have been made. We are now in the default mode. If I click on this first instance, double click on this first instance over here like this, you can see that the first instance has a nominal diameter of 10 millimeters that can be seen or read by this outer diameter, which is 2 times of the nominal diameter, and the height is same as well. I will click on OK and exit the dimensions command. Now I will double click on M12 over here. Here you can see that the height has been changed now from 10 to 12, as it was dependent on the nominal diameter, and in the M12 configuration we specified the nominal diameter as 12 millimeters. Also, the outer diameter has been changed from 20 to 24, as it would be 2 times of 12. Let's take a look at the other dimensions. I will double click on M14, and here the height is 14 and the outer diameter is of 28 millimeters. Also, you can cross verify over here the diameter that we had set for our thread over here has also been changed to 14. It took the reference from the global variable that you had created, and the global variable was dependent on the nominal diameter. Let's take a look at our M8 nut. Here you can see that in this configuration the nominal diameter has been changed to 8, the height is 8, the diameter for the threading is 8, and the outer diameter is 16. Same would have been created for this M6 nut. If we double click on it, it will load the configuration, and here we have the height as 6, this diameter as 6, and the outer diameter as 12. So with the help of equations and design tables, this is how we created all the configurations for our nuts. We first simply created our first nut, gave all the dimensions a reference, that is with the help of equation with the nominal diameter, and once we had set up all our references and equations, we moved to the configuration part. We created a design table, and in the design table we specified the value or parameter that we were supposed to modify, that was our nominal diameter, and we gave different instances for our nominal diameter. And once we had entered all the instances that we wanted to generate, we simply clicked on this green tick over here, and it automatically created these instances. So I hope it is clear that how do we create different configurations by using equations and design table. In order to create all these configurations, you didn't have to create this part over and over again. You just simply had to create the right equations and referencing, and then with the help of design table, we created all these configurations. These are as good as different parts. You can use them wherever you want according to your need. That is, in some case, if I need the M12 nut, I will use the M12 configuration. If in some case I need the M8 nut, I will use the M8 configuration. I hope all the features that you learned in this video were very clear and that you've understood how do you create configurations. I hope you had fun learning. I will see you in the next one.